Okay, I'm sure everyone here has used scientific notation before, or at least talked about scientific notation in your math classes. In chemistry, it's important because we often have to make measurements that are either very small or very large, and that's why we need to have a scientific calculator so that we can use the exponent function on our calculator. So we're going to briefly breeze through how to write numbers in scientific notation. So when we write a number in scientific notation and we're expressing a very large number, it's always written as a product of two numbers, a coefficient that's always a number that is greater than 1 and less than 10 multiplied by 10 raised to some power. So if we're looking at 6,300,000, we assume the decimal to be at the end of the number, and we're going to move that decimal 1, 2, 3, 4, 5, 6 places so that we've got a coefficient that's between 1 and less than 10, 6.3 multiplied by 10 raised to the power of the number of places that we had to move that decimal. So in this case, it would be 6. If we look at 94,700, if we assume the decimal to be at the end of the numeral, we move the decimal 1, 2, 3, 4 places, and we would write it as 9.47 multiplied by 10 raised to the 4th power. Okay, so for the rules for the numbers less than 1, so for really small numbers, we're always going to have a negative exponent. So the value of the exponent, again, equals the number of the places that we had to move the decimal to the right. So if we've got 0.000008, we're going to move that decimal until we have a number that's got a coefficient greater than 1 but less than 10 multiplied by 10 raised to some power. So we would have 1, 2, 3, 4, 5, 6 places we would have to move it to move that decimal to the right to get a coefficient greater than 1. So we've got 8 times 10 to the negative 6 power. On the second example, we move the decimal 1, 2, 3 places, and we get 7.36 multiplied by 10 to the negative 3 power. Okay, now this you may not have talked about before in any of your classes, the difference between accuracy and precision. So a lot of people use these terms interchangeably. There's actually a difference, though. Accuracy is how close, when you're doing lab work, when you're doing some measurements, how close that value is to the true or accepted value of whatever it is that you are measuring. So we know that the accepted value of the boiling point of water, for instance, to be 100 degrees Celsius. So if you measured 3 times the boiling point of water and you got 98 and 100 and 102 and took the average would be 100, and you would be fairly accurate. The precision, however, is a measure of how close a series of measurements are to one another, whether or not they're accurate, whether or not they're very close to the actual value. So again, if you're trying to determine the boiling point of water and you measured the temperature at which water boiled, and you did it 3 times and you got 75 and got 75.1 and got 74.9, and you did it 3 times, you would have very high precision. You got 3 values that were extremely close to each other, but you weren't very accurate. So that's the difference in the two. When you do a laboratory experiment, there is what is called the error for that experiment. And the difference between the accepted value and the experimental value is called the error for that experiment. So the accepted value is what the corrected value is based on reliable references. And for chemistry, there is a huge volume of reference tables called the chemistry, or the handbook for chemistry and physics, and that's considered the most reliable reference. And it's called the CRC. So that's where most of the values that are accepted is going to be held. The first thing when you're trying to find out if you've done an experiment correctly is you have to calculate your percent error. So you find the error and then you plug it into a formula called the percent error. The percent error is the absolute value of the error divided by the accepted value for whatever it is that you are measuring, multiplied by 100. And we will do some examples of these problems in class, and that is all for right now.